my recording. This is not a Zoom recording. This is a screen recording. Okay, so everything's being recorded. Okay, so when you open up that folder that I shared with you, you'll see all these 1, 2, 3, 4, 5, 6 folders. Your robot should be designed in the hammerbot 1 folder. Okay? If I open that folder, I already started a project just because I was playing around with it. It's called hammerbot Geist Demo. I'm going to make another one because I really want you guys to see how to assemble in Fusion. Okay, I really want you to see this, and that's why I'm recording this, okay? So you can always go back to my recording if you miss a step. So while this folder is open, I can create a new design, and you'll see that this is untitled. So as long as this folder is open and I hit the Save button, you'll see that it's pointing to the Robot Rumble hammerbot, and I'm going to call this hammerbot design. I'll just call it 2. My caps lock's on, but whatever. All right. So with Fusion, we are designing top down. In Inventor, we always design bottom up. Okay. What does that mean? Well, bottom up design means that you start with designing your parts and then you drop them into an assembly. Hence the term bottom up. You're starting with your parts and you're working up to the assembly. That is not the best way to design. In fact, it's not a very good way at all. Usually what you want to do is you want to start by designing in the assembly and creating your parts off of the assembly. That way, if something changes in the assembly, those parts are derived from the assembly. The geometry, the sizes, the dimensions. So that's kind of the logic behind it. But since we've already made parts in Inventor and moved them, we kind of have to start with bottom up. So I'm going to start with bottom up assembly. Here's my design. It's empty. I'm going to go to the Robot Rumble folder, into my robot components, and you'll see everything we converted from last year. These are all components. I'm going to scroll down and I'm going to grab the T74 motor. Where are you? There it is. Drag and drop. There it is. It's going to ask me if I want to move or rotate or scale it, and I don't. I'm just going to hit OK. Notice if I click and drag it, it is not grounded. So I do need to right click on my NPC T74 motor, and I need to ground it. I noticed while I was doing this in Fusion that I was still able to move it after I grounded it. Couldn't figure that out at first, but I realized that whoever made this part, it was actually made up of multiple components. So don't ask questions why, but after you ground this motor, you're also going to need to right click and create a rigid group. And that's only because there's multiple parts within this object. So just do this and don't ask questions why until I more understand it better later on. Once it's creating a rigid group, you're going to capture the position and say OK, and now it won't move. Okay? It's stuck there. Now I'm going to grab another motor, a T74, and drop it in. You'll see it lays it almost over it. So I might as well just move it out of the way by grabbing the arrow, just so it's not laying it directly on top of it. And I'm just going to hit OK. Now I've got 2 motors. One, I can't move because it's been grounded. The second one is free moving. So now I want to create a joint. Everything we taught you in Inventor about mates and flushes, you can forget. Okay? Forget it. We're now working in a world with joints. So here's how we do this. We come up to the Assemble menu and we create a joint. Always, when this menu comes up, always capture position, never continue. You understand? Always capture. So what I'm going to do is I'm going to look at 2 selections. And I'm thinking about the 2 surfaces and also the 2 origin points that I want to lock together, almost like a mate. So I'm going to pick first the object that I want to move. I want this face along with this snap point, so I'm going to click it and it disappears, to match up with this face and that origin. And what happens is it moves and it orientates itself. Now, if I didn't like how it was positioned or how it was rotated, I could come over here and I could change the angle, or like in this case, I don't want these motors right next to each other like this. So I'm going to grab this axis and I'm going to drag it apart. How far? I don't know yet. I don't know. I need to make room for batteries. I need to make room for switches. So for right now, I'm going to type in like a random number of like 16. And I'm just going to hit, I'm not going to hit OK. Because what I want you to notice is that if I go to motion, right now it's set to revolute. Revolute means that this will be able to spin, and I don't want that. I want it to be a rigid connection. Rigid means they are not allowed to move. Okay? So when I hit OK, now I can't move either one of these two motors. Let's say I decide later on that I want these to be 17 inches apart. I can always go up to the joints, and I can always go to my second rigid connection, right click and edit, and I can change that distance to be 17 inches. Let's say I wanted those joints to rotate. I could come up here and say I want that to rotate. See? So it can be a rotational joint, but in this case, I don't want them to be. I want them to be a rigid joint. Make sense? So now I've got my motors fixed into place. I'm going to hit save. Every time you hit save, it saves a version. So you can always go back to different versions, which is kind of nice. So I've got my two motors in place. Any questions so far? Okay. Now that was bottom up because I was using parts that were already made and I was building them from the bottom up to create my assembly. Okay. So now I'm going to kind of start to build top down, which is how Fusion was really designed. Okay, that's how Fusion was designed. So what I want you to notice is a little bit about these. I'm gonna close my grid panel or my data panel so it's bigger screen. So the reason it was built this way is that you'll notice that my hammerbot design has this little radio button. This means that I'm looking at my assembly. If I were to come down here and change the radio buttons, I could actually start to view different components, but there's no other components in here yet. I got to make one. So whenever you make a new component, which back in Inventor we called parts, when you make a new component, always make sure that your assembly is activated with this little radio button. So I'm going to come up here. There's this button above assemble. It's called new component. All right. So if I wanted to make a component, I would click on that and I would give it a name. So if I wanted to make like a bracket or if I wanted to make the shell or whatever, I would go new component and I would make that name here and I would hit OK. But you guys are going to make a sheet metal part. So it's a little bit different. You're going to go to sheet metal and then you're going to click on new component. Okay? So since this is kind of advanced and you guys haven't even really made a part yet, I kind of want to just show you first how to make a basic part. So I don't want to start with sheet metal. I want to start with just solid. So here's a new component. Let's just say bracket, because maybe you'll have to make stuff like brackets, right? So if I say OK, take a look over here. It now shows bracket, and everything else grays out. So if I make like a sketch and maybe I start it off of this top surface of the motor And I won't go crazy on it. I'll just draw a rectangle and extrude it or something. Again, this is nothing of any significance, but there you go. There's my bracket, okay? But look, it's a separate part. Now, if I want to see everything in my design, I got to go back up to here and activate the assembly. But here's what's going to screw you up. Now watch carefully. When I go and grab that part I just made, it moves. Uh-oh, hit undo. Every component that you make from the assembly, don't move it. After you jump back out to the assembly, don't grab it and move it. Undo. You have to create a joint. Or if it's something that's never ever going to move, like a bracket, then make it, go to assemble, make it a rigid group. Say, I want that to be a rigid group between here and here. Done. Now it won't move because it's a rigid group. Make sense? Or I'm gonna go over here and I'm gonna delete that rigid group. Maybe this is supposed to slide. Okay, assemble, joint, and then you would pick this part to this part, and then you would pick, right now it's on revolute, maybe you pick slide. Maybe I don't want it to slide in that direction, maybe I want it to slide along the X. Or maybe I want it to slide along the Y. Now I'm not trying to teach you all of these joints today. All I'm trying to teach you right now is that after you create a component and you go back to assembly, this part is not constrained. Undo. You need to create a joint or make it a rigid group before you move on. Any questions about that? Most of your stuff in your robot is going to be a rigid group, right? I mean, how many things are moving besides a wheel? Most of your stuff is going to be a rigid group. So I don't need this bracket. I just wanted to show you how to do that. So I'm going to delete the bracket. You guys are going to make a sheet metal part. So that's why I'm glad I'm recording this, because I'm sure you're going to have to go back to this. But here's your sheet metal part, okay? You're going to go to sheet metal right here, and you are going to go first, and you're going to define how thick the sheet metal is. You guys, I recommend use an 1/8 inch thick sheet metal. That's how thick your sheet metal should be. That's what we have out in the shop. So go up to Modify and go to your sheet metal rules and open it. Go to your library, go to your steel, and click the little pencil, and edit the rule. Your thickness is 3.25 millimeters. How do I know that? I Googled what is 1/8 of an inch in millimeters. That's all. And it came out to be 3.25 millimeters. That's all you got to change in that. And you can go back to this recording if you forgot. Close. And now that we're in the sheet metal tab, I'm going to create a new component. This component is going to be called, I don't know, bottom shell. Use good naming. I'm going to say, don't do that unless this is, activated at the assembly level. Don't hit OK unless you're sure of that. Make sure you're picking the right sheet metal. Like open this arrow, make sure it's at 3.25 millimeters because there's a lot of different sheet metals to pick from. I'm good. So I'm going to say OK. And now look, I'm activated on my bottom shell. That is the component that I'm working with. Perfect. So now I'm going to make a sketch. Watch what I do. I'm going to go to the underside of the robot. And I'm going to pick the bottom face of this motor. Just right like that. There's the bottom face. Now I want the sheet metal to kind of wrap the bottom and then come up the sides of the motor. So I'm going to go to Project Geometry, which is under Create, Project, and I'm going to pick and I might have to tilt my screen a little bit to see what I'm clicking on, but I want to wrap the sheet metal over the furthest outermost edge here, the furthest outermost edge there, and I'm going to go back to a top view, and I want it to go all the way to there. So there's my 3 edges. You'll see why and how I'm doing this in just a second. That edge. So this edge, and this edge. And I'm going to go to my other motor. I'm going to pick those same surfaces. Oops. So that edge, that edge. I'm creating edges so I know how far my rectangle goes. Now, watch. I'm going to draw a rectangle from that corner all the way to, it's hard to see in wireframe, to that corner. Finish my sketch. Now I'm going to hit Create a Flange. I'm going to pick this shape. Make sure you pick the whole rectangle. And make sure it's automatically going to extrude the thickness of whatever the sheet metal rule is. And there we go. Now if I go back to my assembly view, you're going to see a sheet metal bottom. See it? I don't know if I came out far enough. Yeah, I did. See? I don't know if I'm going too quickly, but again, it's a video, so you can always go back. Now I'm going to activate my shell again, and this time I'm going to hit Flange, and I'm going to click on these 2 edges. And I'm going to type in a distance. I think maybe 4. And now it automatically creates the bend and it curves up. See it? But I have a little bit of a problem because if I go to my front view, do you see how it's curving up and it's hitting the motor? That's because of the bend position. I'm going to change my bend position to outside. Now it works. So there's different bend positions. If I go inside, it's based on where the bend starts. So you got to be careful and really look closely at where you're bending. So if I go inner or outer, oops, hold on. There we go. And then how high up do we want to go? I don't know. Is that hitting something here? I think it might be. I'm going to hit OK. I'm going to go back to my assembly mode just so I can see if there's any collision. See if I'm hitting anything. Doesn't look like it. Now, let's say I wanted a flange to come forward because I want to bolt this in every possible position. Watch. If I wanted a little flange to come forward here, I can click. Well, first I got to activate my bottom shell. And now watch how I do this. I'm going to click Create a Flange. I'm going to pick this edge, right? I'm going to have it come in 1 inch. I don't want the whole thing to come in though. I'm going to, instead of full edge, I'm going to go down to 2-side offset. And now I can specify by typing in numbers how far, and I can use negative numbers. I'm actually going to use 0 and then -2. Well, maybe a little bit more, 2.5 maybe. Maybe -3. There we go. And now it just covers the hole. Why can't I hit OK? Something didn't work right. Hang on, let me do that one more time. This edge, 2-side offset, -3 for a distance of 1. Huh, wrong edge. Oh, I guess you can click and drag too. That's kind of cool. Look at that. Oh, that's even easier. Click and drag, guys. Nice. Look at that. Beautiful. Click and drag. And then if you want a hole, just make a sketch on the face. You can project geometry. So go project. And you can project the motor hole. Boom. Now that hole is there. And now, finish your sketch. Sheet metal, there should be a cut. I didn't look for it yet. Where's cut? Oh, I guess they have extrude. Extrude works too. Just cut. And now you have a hole. So when you're all done, because then there's going to be another half on top that kind of goes together like this, right? That was kind of the thought. And then you can do something so that this can be connected. Whether you have like a U shape with a bolt that comes together, I don't know. You can figure out how it can be connected. But this is going to reduce a lot of weight because you don't have the frame anymore. There's no more pipe, right? And then what we can do is, when you're all done, we can unfold this. So I'm going to hit save. Okay. And if you were to make another like top piece to this, remember, first go to your assembly, then go to create a new component. And call it, you know, top shell or whatever you're going to call it. Hit OK, you know, pick this surface or whatever you're going to pick as your top surface, and then start building. See how it's a second part underneath this big assembly? The nice part is you can unfold these. I haven't done that yet, so I'm getting kind of scared here to demonstrate something. Oh, unfold. So if you hit unfold, I think... Oh, stationary here, and then you can hit the bends there, there, and there. See? And now look, you've got a flat piece. And now we can cut it on the plasma cutter. Isn't that cool? And then you can refold it. But don't ask me how to refold it because I haven't figured that out yet. I'll just undo. All right. So this has been recording for 23 minutes. Wow, that's a long recording. All right, I'm going to stop this.